Okay, here we have a diagram of the water cycle, also known as the hydrologic cycle. Hydro, of course, to do with water, so we can just call it the water cycle, that's fine. Now this shows the storage and movement of water between what we call the four spheres of the Earth. The spheres are the biosphere, the atmosphere, the lithosphere, and of course the hydrosphere, since we're dealing with water. So those spheres, bio of course means life, so the biosphere is where you find living things. Atmosphere, or atmo is the Greek for vapor, so it's the gases surrounding the planet. And we have the lithosphere. Litho is Greek for stone, so it's where we find the hard rock, so the crust in the top part of the mantle. And of course hydro, being the prefix meaning water. So these are our four spheres of the Earth: biosphere, atmosphere, lithosphere, and hydrosphere. And here is a cycle of the water cycle, showing how water moves between these spheres. So let's start off in the ocean. All right, so we've got lots and lots of water in the ocean. In fact, 97% of water on the Earth is found in the ocean. So actually, let's pause on the water cycle for a little bit, and we'll say, well, where is the rest of the water? We start with 100%. Okay, great. Now, 97% of that is in the oceans. I say oceans, really there's only one ocean. There are 5 named oceans. We have the Pacific, the Atlantic, the Indian, the Arctic is the 4th one, and 2010, a 5th ocean was named. That's the Southern Ocean around Antarctica. But really, of course, it is just one global ocean. But anywho, 97% in the ocean/oceans, depending on what you want to say. Where is the rest of the water? Well, we have 3% left. So where is all this stuff? Actually, two-thirds of this stuff is frozen. So of that 3%, 69% of that, so roughly 2/3 is frozen. So where do we find this frozen water? Well, mostly in Antarctica. 90% of the frozen water on Earth is in Antarctica. It's a big place, Antarctica. Another 9% in Greenland, because, Greenland is icy and Iceland is lovely and green. But anyway, so 9%. And then it leaves us 1%. Now remember, this is 1% of the 69% of the 3% left over that's not in the ocean, right? So it's not all that much. 1% is other ice, so glaciers, right, up on top of a mountain, things like that. Right? Cool. Glaciers, mountains, your freezer at home, I suppose. Okay, now that was only 69% of the 3%. We've still got some more left over. So where is the rest of the water? Well, 22% is in groundwater underneath our feet. Now, groundwater we're actually going to mention shortly when we actually get back to the water cycle. So 22% is groundwater, 8% is actually inland seas. So 8% inland seas, like the Dead Sea, things like that. Inland seas, actually the Dead Sea, poor little thing, it's drying up. One day we won't have the Dead Sea anymore because it's very high rate of evaporation, but very small amount of new input into the Dead Sea, so it is actually drying up. What about this drinking water that we can use for us, because we do like to drink water? Well, a lot of the world's population actually gets its drinking water from the meltwater of the glaciers up in the Himalayas. But really, we've got, take all these numbers away from our 100%. We're left with roughly 0.3% of the 3% of all the water, fresh water in rivers and lakes. So in terms of fresh water available to us nice and easily, really not all that much. 0.3% of the 3%, right? But like I say, glaciers melt. A large proportion of the Earth's population gets its drinking water from the meltwater from glaciers. So anyway, let's get back to the water cycle. Most of the water on Earth is really in the ocean. Okay, so 97%. How do we get it into the atmosphere? because we do, of course, have water in the atmosphere. Remember, this water cycle links the 4 spheres of Earth. So we're starting in the hydrosphere, one part of the hydrosphere, where there's water. Anywhere there's water is the hydrosphere. So we're starting in the ocean, and what can happen is the water evaporates. So we have evaporation. So there we go. We now have water vapor up in the atmosphere. Great. Now we don't just have evaporation from the ocean, we also, of course, have it from land. So let's just write it there as well, because we're going to group this one with another one in a minute. So we've got evaporation, that puts water up into the atmosphere. Cool. Do we have clouds? No, not yet. We have water vapor in the atmosphere. Now, what can happen is that water can condense. So we've got condensation. That's how we get our clouds. The water vapor, the gaseous water, condenses to form tiny little droplets of water, and those little liquid droplets of water are what actually make up clouds. Now, water is completely replaced in the atmosphere about every 8 days or so. So it can't stay in the atmosphere, but that's okay. We've got some arrows coming down. Let's look at the one between these evaporations. That is, of course, precipitation. So basically it can rain. So evaporation puts water vapor up into the atmosphere. That water vapor then condenses to form droplets of water, and then we've got precipitation. Better finish off the word before I keep talking. Then we've got precipitation. Now, there are a few different types of precipitation. Basically, if liquid or solid forms of water, if it can overcome the atmospheric updrafts, then it can fall to the earth, and we call that precipitation. But this includes things, just put an example. Everyone thinks, oh, precipitation, yeah, that's rain. Well, rain's an example. We also have freezing rain, ice pellets, snow, hail. So we've got a few different sorts of precipitation, but that's where the water, whether it be liquid or solid, it's where it gets returned back towards the earth. Now that's a nice cycle. It's leaving the ocean, it's going up, it's leaving the land, it's going up, and then it's raining, it's coming back down. So that's a cycle. There you go, water cycle done. Except it's not quite done. We have some more arrows to do. Now, of the water that evaporates from the ocean, not all of that falls back into the ocean. In fact, the oceans supply 86% of evaporated water to the atmosphere, but only 91% of that water actually falls back to the ocean. So the remaining 9% is transported over land, and it comes back over land. So there's the reason for the difference there. Now, so it was transported over land. Here we go. Look at the top. We see clouds moving. So the cloud may have formed over the ocean, but then it moves over the land, and then maybe it will rain. So the moving of the cloud is called, start with the right letter, advection. Now, advection is the movement of a fluid from one place to another. So that could be a gas or it could be a liquid. Okay, so advection is when the clouds move. So first we condense to form the cloud, and then the cloud moved somewhere else, and so that process is called advection. Okay, how else could we possibly get up into the atmosphere? Well, there's another arrow coming off a tree. Now that is called transpiration. Let's write that one in. Transpiration is water loss from vegetation. Okay, it's the process where plants lose the water through the stomata on the underside of the leaves, and that water vapor can go up into the atmosphere. So we don't just have evaporation, we also have transpiration. Now, I mentioned I was going to come back to that evaporation off land, and let's do that now. Let's call this transpiration is 1. The evaporation over land, we'll call it 2, because then we can do a little bit of math. Don't worry, it's not too tricky. We're just going to say 1 plus 2. We can combine those. We can talk about water going into the atmosphere from land, so that could be evaporated water, or it could be transpirated from plants. And we give them a new name. So 1 plus 2, we actually just combine the two names. Evaporation plus transpiration gives us evapotranspiration. Transpiration. Okay, the word gets a little bit on the longish side, but there we go. So we can talk about evaporation from the sea or evaporation from land, or we can talk about transpiration from plants. That also puts water up into the atmosphere. But if we're talking over land, transpiration and evaporation, we can combine those and just use the word evapotranspiration. Cool. So it could rain over land. That's grand. We've covered precipitation already. Another way that the water could come to land, and this is not in liquid form, this is in solid form because we're talking snow. So up high on this mountain here, we could have deposition. So this is where a gas becomes a solid straight away without condensing first to a liquid. So it sort of bypasses that liquid phase. Instead of going gas and then condenses to a liquid and then freezes to a solid, no, we just go straight from gas and it deposits, usually around a deposition, a nuclei, something like a dust particle or something in the atmosphere. So an example of this would be snow, because that's how snow forms. Snow is not frozen water droplets. That you'd call hail. So deposition nuclei is up in the atmosphere, some little particle of something, and then the water deposits around that, and we call that a snowflake. Now, it can go back the other way, of course. We can go from solid straight to gas without going through the liquid phase. And this one is what dry ice does. Okay, dry ice being frozen carbon dioxide gas, and if you just leave that, it will turn back to a gas. It won't melt and then evaporate, it will just go straight to a gas. And this is the process of sublimation. So these two chemical processes also occur as part of the water cycle. Okay, so maybe it did rain. So we've got liquid water on the ground, and we have a bit of a slope, you'll note. So the water is going to run down the slope, and this is what we call runoff. Runoff is the surface flow, the surface movement of water, essentially moving from a higher point to a lower point because, gravity is a thing. So that's what we call runoff. Now, not all the water, when it rains, it just runs along the surface of the soil. Some water actually goes down into the ground. The ground gets infiltrated, which is why we call it infiltration. So infiltration is the movement of water. Instead of running off the surface, it's the water movement down into the soil layers. But then it could... We could have runoff a little bit below the surface. You could call it subsurface runoff. In fact, we'll give it two names here. So we could have subsurface runoff, or you could use a bit of a different name, through flow. So also known as through flow. Can't really see the arrow anymore, but that's okay. It was there at the start. So runoff is surface water. We're going from a high elevation to a low elevation. If the water is actually moving below the surface, we call it subsurface runoff, or you could call it through flow, either or. Now, sometimes the water doesn't just infiltrate the soil layers, but it actually sort of percolates down lower and reaches the groundwater. So it reaches the bedrock and saturates it. So then we have the water table, and this is referred to as groundwater. And how did it get there? Well, I did actually just say it percolates down, sort of works its way down through. So we actually call it, funnily enough, percolation. Remember, sometimes science just makes sense. If it infiltrates, well, let's call it infiltration. Then it percolates down, well, let's call it percolation. So a lot of times science just makes sense, right? Sometimes it might seem not so much, but sometimes it does. And there we go. So that's the water cycle. Water's gone up into the air, it's come back down, it's run off the land, back to the ocean, started all again. Maybe it went down into the ground because it infiltrated, maybe percolated. And so we've gone through the different spheres, the biosphere, atmosphere, lithosphere, and hydrosphere. Of course, we didn't actually... Oh, sorry, I was just going to say, well, we didn't mention the biosphere. There's no picture of the biosphere here, but yes, there is. There's a tree. So there you go. Biosphere is living things. Atmosphere is where there's gases around us. The lithosphere is the hard, rocky surface like of the crust and upper mantle. And the hydrosphere is basically anywhere you have water. So there we go. There are some different reservoirs of water and how the water gets around. Cool. Let's call it the water cycle.